Okay, I'm going to pick up with question number 13. I stopped at 12 because we were just simplifying, multiplying, and dividing. Now we're going to get into some adding and subtracting. So the rule for adding and subtracting is basically in order to combine, you must be the same kind. And to determine if they're the same kind, you look at the number underneath the radical sign. And if they're not the same number, then they're simply not the same kind. So in its present state, we cannot subtract them. However, what you need to do is to try to simplify each one to see if you can force them basically to be like radicals. So I see some perfect square factors embedded in both of these numbers. And so I'm going to convert the square root of 4 to a 2 and the square root of 25 to a 5. And now when you subtract these, don't make the mistake of removing the square root of 3. It's kind of saying right there something to the effect of 2 basketballs minus 5 basketballs, or $2 minus $5. And again, what you're referring to is an object. So the object here is the square root of 3. So we have 2 square roots of 3 minus 5 square roots of 3, which is simply going to give us negative 3 square root 3. Okay, the next one. Again, in present state, we cannot subtract them. However, 45 does have a perfect square factor embedded in it. And it's going to equal 3 times the square root of 5 minus the square root of 5. Again, don't just remove the square roots of 5. That's a very common mistake. It's just to take off the square root of 5. But it's really telling you have 3 square roots of 5 minus 1 square root of 5. How many square roots of 5 do you have left over? And the answer is going to be 2 square root 5. Okay, again, let's look for some perfect square factors embedded. 36 times 2, and then 9 times 2. And the square root of 36 is 6. And so now we're being asked, what is 6 square root of 2 minus 3 square root of 2? And they are the same kind now because the number underneath the radical are equal. So 6 minus 3 is 3. 3 square root of 2's. Okay, number 16. Again, this was really actually probably should have been done at the very front, but again, there's something to be learned about that square root of 5. How many of them do you have? There's not a number in front of it, so there's an implication that it's the number 1. So if you have 1 square root of 5, and you add 2 more square roots of 5, then you're going to wind up with 3 square roots of 5. Okay, again, 27. Yes, the perfect square factor embedded in it is, you got it, 9. And so when we convert that 9 over to a 3, we get 3 root 3 plus the square root of 3. Again, there's a single square root of 3 being added with 3 square roots of 3, which gives you a total of 4 square roots of 3. Okay, I should say the 4 times the square root of 3. That didn't sound right. Okay, moving on, number 18, again, cannot add them in present state because the 44 and 11 must be the same number, and obviously they're not. So 44 does have a perfect square factor embedded in it. It is the number 4. I'm going to show you what to do at this point. When you simplify, the square root of 4 becomes a 2, and what do you do with the 4 that's already on the outside? Well, the answer to that is you multiply. You don't see an adding or subtracting sign in between those radical signs, so it's all implying multiplication. So we get 8 square root of 11 plus 5 square root of 11, and that's going to give us 13 square root of 11. Okay, now this one is slightly different. Again, we cannot leave a radical in the denominator of the fraction, and so first thing we should do is maybe look for a perfect square factor embedded in that and simplify it. And now what we want to do is that square root of 5 is not allowed to stay where it's at. So in order to remove it, we're going to multiply this by a fancy form of 1. That fancy form of 1 is going to be identical to the radical in the denominator. And you can also actually divide 8 by 2 to get the 4, so you can cancel those out as well. So we're going to take 4 times the square root of 4 over the square root of 5 times your fancy form of 1. And that gives you 4 times the square root of 5 over the square root of 25, which is 5. Mission accomplished. We do not have a radical in the denominator. It's perfectly okay to be in the numerator. Let's try another one. Again, the best way to handle these is to simplify first. So let's go ahead and look for a perfect square factor embedded in 12. And we see that it is the square root of 4. So we're going to change that to a 2. And our fancy form of 1 is going to be the square root of 3 over the square root of 3. Whatever the radical is in the denominator, that is what you're going to create a 1 out of, a fancy form of 1 or a form of 1. And now multiply 3 times the square root of 3 in the upstairs, and 2 times 3, where'd the 3 come from? Well, that's the square root of 9, and the square root of 9 is 3, so now what we can do, we could multiply those together and get 6, but I'm noticing that I can also strike out the 3's in the numerator and denominator. Again, that forms a 1. So my final answer is the square root of 3 over 2. And again, we have 4 times 6. The square root of 4 is 2. We can cancel out 6 divided by 2 is 3. And now our fancy form of 1 is the square root of 6 over the square root of 6. And we get 3 times the square root of 6 over 6, and we're not done because we can divide 3 6, change it to 1/2. And our final answer is the square root of square root of 6 over 2. 22, this one is slightly different. If we put these underneath one roof, we can strike out the 6 and the 3. 6 divided by 3 is 2. And so now I can put the 2 in the numerator, and I can now split these back up. That's the beauty of multiplication and division, is you can take them apart, put them back together again. Take them apart, put them back together again. Kind of like Humpty Dumpty. Sorry, I had to throw that in there. Okay, so now we have 2 over the square root of x, and again, our fancy form of 1 is whatever is in the denominator. So in our numerator, we're going to get the square root of 2x. In the denominator, we're going to get the square root of x squared, which is x. All right. Again, please note, if you put those underneath one roof, you can reduce the fraction and now split them up again. The square root of 1 is 1, so now you're left with 1 over the square root of 5. Can't leave the square root of 5 there, so we're going to multiply it by a fancy form of 1. That 1 is going to be created from the denominator. And now as a result of this, it cancels out the radical in the downstairs because you get the square root of 25, which is 5. All right, moving on. Again, let's go ahead and strike out the 40 and the 50 and make them 4 and 5. And now, geez, this is easy because now the square root of 4 is 2. And my fancy form of 1 is just simply going to be root 5x over square root 5x. Multiply your numerators together, denominators together, and there's your final answer. Cannot simplify this one. Cannot simplify it, so I'm going to simply break it up. I can divide 4 into 8 and make that an x squared. And here's where it changes a little bit. I need 4 6's in order to cancel the denominator. So my fancy form of 1 has to create 4 of a kind. So that fancy form of 1 is going to be 6 cubed. Let's try to understand that. You've got 1 6 sitting underneath the radical. You need 4. So the fancy form of 1 is just simply going to be 6 cubed times 6 cubed. That gives you 4 in the denominator. And you can see from past that the 4's do cancel each other out because they're inverse operations. 6 times 6 times 6 is 216. It cannot be simplified any further. So your final answer is x squared times the 4th root of 216 divided by 6. Okay, now this one is going to involve a little bit of distribution. We have multiplication of 2 binomials with radicals. So again, just as we've done in the past, this is also in the template a plus b times a minus b, which is When you multiply those two out, you get a squared minus b squared. So you can FOIL this out. You're going to see that the inside and outs, two inside terms are going to cancel out because they're inverses of each other. And you get the square root of 9 minus the square root of 25, which is 3 minus 5, which is negative 2. Now the next one, you don't need to jump the fence and just square the 2 and the 7. You do need to write those out and use the FOIL method or the distributive property. So 2 times 2 is 4. 2 times the negative square root of 7 is minus 2 root 7. Now you're going to distribute the negative 2 root 7 to the 2. You get the same thing. And then negative square root 7 times negative square root 7 is positive square root 49. And now let's clean things up a little bit. We can get 4 minus 4 root 7 plus 7, and now we can add the 4 and the 7 together to get 11 minus 4 root 7. Okay, there's one more. And again, we're going to use the distributive property. 4 times 5 is 20. 4 times 2 root 11 is 8 root 11. Negative root 11 times 5 is minus 5 square root 11. And negative square root 11 times 2 square root 11 is negative 2 square root 121. The 121 changes to 11. The 2 times 11 becomes a 22. And now you can simplify. 20 minus 22 is negative 2. And 8 square root 11 minus 5 square root 11 is 3 square root 11. Alright, this concludes this video. This was a little bit longer than the other one. I hope it helps, and we will see you in class.